In this class, we find out the coordinate of center of gravity of a volume of revolution. Okay. Now the problem of this class is the area bounded by x-axis, the line x equal to 2 and the parabola y equal to x square is revolved about y-axis. Okay. So this is a volume of revolution since this is given that is revolved about y-axis. Find the centroid or CG of the resulting volume. Okay. We first draw a rough sketch of the area first, then we try to sketch the volume of revolution. Here it is given that this is x-axis, this is y-axis, and y equal to x square be a parabola look like this. This is the parabola. Y equal to x square. Right. Now the area bounded by x-axis and x equal to 2. X equal to 2 means this. Okay, this is x equal to 2. We let here x equal to 2. So that is, if we take, this is the point A and this is given by 2, 4, because if we put x equal to 2 then y equal to 4 and x-axis is this, so this area is revolved about y-axis. If this shaded area revolve about y-axis, then we see that we get a symmetric volume. Symmetric volume about y-axis looks like this. Okay, and this is, we let this is B and this is minus 2, 4. Okay, and if we take, this is M, this is N, so this is minus 2, 0 and this is 2, 0. And the volume is this shaded area. Okay. And if we draw here a circle and also here a circle, okay, to show the picture correctly. This is not the area, this is the volume about y-axis. Okay. But there is a problem since there be an empty volume in between these two volumes. Okay, so here we use to find the CG of combined body. What is the formula of finding out the CG of combined body? Let us see. We first try to find the name of two bodies. The first body we name here, let it be origin, it be K. So the first volume is given by O A O A B O, O A B O, sorry, O A K B O, K B O. This is the first body. Let its volume be V1. Okay, and we let the whole body M A B N M. Okay, that is the total body, and we find the coordinate of CG one by one. First for V1, second for V2. Then we use the formula of combined body CG. Okay, and another volume we write here. This is A B N M A, and this volume is, this is equal to V2. Now it is clear that two body, that is the volume V1 and volume V2, both are symmetric about y-axis because there will be same volume on the left and right side of y-axis. So the center of gravity of two bodies must lies on y-axis. Okay, let for the first body it be 0 comma y1 bar, and let for the second body this is 0 comma y2 bar. Okay, for the first body we let this, and for the second body we let this, because center of gravity of two bodies lies on the y-axis. Let it be at g1 and it be at g1 and it be at g2. Okay, now we first find the coordinate y1 bar, that is the center of gravity of the first body. For the coordinate y1 bar, we take any point on this curve y equal to x square. Okay, and we consider a strip like this. Clearly this strip is of breadth dy, and if we take this point P, this is equal to xy, so the distance of this strip from x-axis is y, and if this strip revolves about y-axis, then we get a circular region like this. Okay, this is the circular region. We get this region, and by revolving we get a circular region, and the volume of the circular ring, not circular region, a circular ring, which is given by pi x square, because the radius is x, this is x, and its breadth is dy. Okay, and this is the volume of the circular ring. If we multiply it by rho, that is by the density, then we get the mass, and this is the elementary mass for our problem. Okay, so we write here integration rho pi x square dy, and the distance of this circular ring from x-axis is y, so we multiply by y, and in the lower integration we write only rho pi x square dy, that is the total mass. Okay, we cancel out pi and rho. And what is the range of integration? We take the point P from 0 to 4, because here y equal to 4. Okay, so we get this is y equal to 0 to 4, and here also y equal to 0 to 4. Now this is given by integration 0 to 4 y into x square. X square means also y for this curve, so we put another y dy by integration 0 to 4, this is y dy. So by integrating we get this is y cube by 3, and this is the range is 0 to 4, and this is y square by 2, the range is 0 to 4. So we get 4 to the power 3 by 3 into 2 by 4 square, that is we get 8 by 3. So the coordinate of G1 is 0, 8 by 3. Okay, now we try to find the value of y2. Now to take another point on this line. Okay, this is P and its coordinate be 2, y. Okay, because this is the line x equal to 2, it is given, and if we consider a strip here, if we consider a strip and if this strip be revolved about y-axis, then the radius of this strip is x equal to 2 here, okay, because the point is taken on the boundary, and this ring shape volume looks like that. Okay, so for elementary mass we let pi into r square. R square means the radius, this is 2 square, into dy. Okay, and this is the elementary mass, so this is 4 pi into dy. So on the upper integration we write first 4 pi into dy, and the distance of this circular strip or circular ring is given by, this is y. Okay, so we multiply here by y, and in the lower portion we get 4 pi into dy, and we take this point from y equal to 0 to y equal to 4 to find the center of gravity of the whole body, that is the volume V2. Okay, now this gives y equal to 0 to 4, and this is also y equal to 0 to 4. We cancel out 4 pi, and we get y square by 2, 0 to 4, and this is y 0 to 4. So this is 16 by 2 into 1 by 4. So this is 2. Okay, so the coordinate of this is 0, 2. Now we have to find only the center of gravity of this portion of revolution O, A, M. This portion or this area revolve about y-axis. Let the coordinate of the required volume or coordinate of CG of the required volume is G. This is also on the y-axis due to symmetry about y-axis, and this is 0, y bar. Okay. Now we already see here what is the volume of V1 and what is the volume of V2. We first find out the volume V1 and find volume V2. So volume V1, this is given by, this is the volume V1, and this integration becomes this, so it is given by, we already cancel out 5, so here we write integration 0 to 4 rho pi x square dy, and this is rho pi into y dy, and so this is rho pi into 16 by 2, that is 8 rho pi. This is the volume V1, and for the volume V2 we write this. So V2, this is given by 0 to 4, and the lower term is 4 pi dy, so this is 16 pi rho. We also multiply rho here. Okay, and this is the volume V2 and this is the volume V1. Now we use the formula of CG of combined body, which gives y bar. This is the whole body is given by V2, so V2 into y2 bar minus V1 into y1 bar, because this is the body inside the whole body. We subtract this body to get the required body by V2 minus V1. Okay, this is the formula of CG of combined body. If we add two body, then there will be plus, and here if we subtract one body from another, then here minus. Okay, now put the value of V1, V2 and Y2, Y1, and we get the result as V2. This is given by 16 pi rho into Y2 bar. What is Y2 bar? This is 8 by 3 minus. This is given by V1. V1 means 8 rho pi. This is V1. And Y1 bar, this is given by, this is 8 by 3 and this is Y2 bar, this is 2. Okay, this is 2 minus, this is 16 pi rho minus 8 pi rho. We cancel out pi and rho and get the result as 32 minus 64 by 3 by 8. And taking common 32 from this, we get 32 by 8 into 1 minus 2 by 3, right? And this is 32 by 8 into 1 by 3, that is 4 by 3. So the coordinate of CG of the combined body or the required body is given by G. This is 0, Y bar. So this is G 0, 4 by 3. Okay, and this is our required answer.